Okay, folks, you had a good break. Coffee is in you. Did the coffee cause or remove emotional fatigue, mental fatigue? Did it remove it or cause it? Remove? Okay, good. Now, what are we talking about here? We've got okay. Are we all fully on this one? Do we understand what this is telling us? Okay. So this gentleman here asked me, how do I measure force from EMG? Now, I have shown to you a diagram, which in my lovely drawing ability, and by the way, I love your handwriting. All of you guys have got such good handwriting. I wish I had even half as good as you do. I can't. I often cannot read my own handwriting. So back to this one. This is blood flow, by the way. If you can't read, this is muscle end plate, and this is the electrodes. Now this is all happening. Okay. Now, when I have got very little amount of force, very little amount of force, how is this signal going to look like? I'm drawing here, which is load equal to very small. How is this going to look like? This is a 0 line. Can you help me with it? Any volunteers? How many of you know some electronic signal processing, anything else? The gentleman in the black. Yes, you. Tell me. You can keep sitting. Just help me draw. This one. You remember how we got yesterday we got the EMG, the triphasic signal, etc. What is going to happen now? Let's give you a microphone. Can you pass it on to him, please? The back.
Sir, hello. Can you repeat the question? Yeah.
Okay, I have got these two electrodes.
Yes.
This is my skin. This is my epidermis. This is my fat. This is my muscle. And in the muscle, this is where my end plates are located. Yes. These are my electrodes. This is what I'm getting.
Yes.
How will this signal look like when my load is very low?
It's some sinusoidal types.
Anyone else? How will it look like? Will it look like this? And what is it? What is the duration? We're not only having one motor unit, are we? So typical situation would be that my signal would look like okay. Now I increase the load, L is equal to small. And this will become, what is going to happen? There are two things going to happen. More number of motor units and increase in frequency. So I'll have a little bit higher and number of, I've drawn that wrong. Maybe let's redraw this one. See you later. Now it becomes narrower and taller. Then I have even larger. And it'll become, right? Okay. And if it is very large, it'll start swinging even more. Okay. So the question for you for tomorrow will be, if I am getting a signal like this, how am I going to measure that this is very small, this is small, large, and very large? What am I going to measure? What feature? One of you asked me the question feature, relationship of feature with the, did you ask me? No. One gentleman asked me this question. Pardon? Bala. There you are. Bala, you asked me this question, right? So now you can play around with it and you can figure out something. You won't know the answer, but you'll get the gist. Okay. Now, what is this going to depend upon? Okay. Maybe because you want to do it computerized. Maybe you want to do some automation. Maybe you're not able, and there are many other factors might come in. And maybe it is not just the magnitude. What is it that you're going to measure? I'm not saying yes or no. I'm only throwing you the problems. Okay. Now let's go back to this one here. So one of the factors which goes into the signal is the force, right? Okay. What is the other factor that has gone into this signal? Pardon? Skin impedance. So skin impedance. And what does skin impedance depend upon? No, fat is separate. We'll come to that. Skin impedance is skin. And skin impedance depends upon the skin thickness in itself plus the skin moisture content. Right? So skin properties. Then your fat. Right? Then distance from end plate. This distance. Okay? What else? You want to tell me? What is one more factor which is going to contribute to the signal shape? Huh? Motor neurons. So the rate at which the motor neurons are coming, right? Okay. Well, in that case, then we'll have one more activity. One more factor. Someone in the back there. Anyone volunteer? Pardon? Yep. Tell me. Where's the microphone? Can you give the microphone to him, please?
For what, sir?
This shape of the signal that we are recording here has got many factors. Force is one of them, skin impedance, fat level, distance from the end plates, multi-unit activation. One more. Type of electrodes. Electrode material, you mean? So that would no type of electrodes. If you're talking about material, that would actually contribute to the same as skin impedance, because that's a combination. The skin impedance and the electrodes together make the skin and the electrodes together make the skin impedance. Pardon? Fantastic. Inter-electrode distance. And then on top of all of this, there's one more factor which we studied in the previous section, and that is muscle fatigue. Right? Now, if you only want to find a relationship of this with force, you have so many other contenders. Each of these is going to influence this signal. Okay? Does that answer your question? Do you think that answer? He wanted to know, can he use EMG to measure force? Do you think I have given him the answer? And what is the answer? Again, someone at the back. The lady in the black. Give her the microphone. What's your answer? Do you think I've given the answer? Have I given the answer or no? Give it a go.
No ideas.
No idea. Someone else? You, ma'am? No? You at the back? No? You in the blue shirt? Yes, you. Is that blue, right? Yep. Give it to him. He knows the answer. Huh? At the head. Yeah.
From EMG data, we cannot find the muscle force directly.
Correct. And the reason, because
Some other parameters.
there's so many other parameters that are contributing towards it. So yes, you can have an estimate, but because of so many other factors. So in general, what you can do is inter-electrode distance you can fix. Okay? You can say there was no muscle fatigue. You can start off with. You can also, if you are doing for the same person, then you can say, well, the fat is remaining the same more or less. And if you use the electrodes together, you can, even then you cannot say skin impedance is the same, because skin impedance is not only based upon the electrodes, the skin property, but it is also based upon the pressure, whether you put some pressure on it or not. That becomes an issue. Again, motor unit activation can also be related to the force if there is no fatigue, so you can get rid of that. So you can, if you remove all of those assumptions, you can get an estimate of the thing, as long as you are aware that there are so many other factors. Okay? Is that all right? Okay. Now, there is one more factor which comes in. Are you familiar with the word isometric? All of you know this word? If you don't know it, just do a quick Google search and read it. Pardon? So what is isometric? Pardon? So a fixed length. Right? Now, there are three kinds of situations. Isometric, when the muscle generates the force without any movement. Then there is one where the muscle generates the force and the muscle's length reduces. Pardon? Not necessarily constant force. What is it called? Someone check me. When it moves in the direction. Pardon? No, check. Give me the exact word. Muscle contraction with shortening muscle. And then I'm going to give you the opposite question. Muscle contraction with while the muscle is increasing. What is it called? Pardon? Concentric, and the other one is eccentric. Why am I asking you these questions about concentric and eccentric? Have you, any of you, ever been trekking to a hill or a mountain? Anyone? You have? When you walk up, what happens? You get exhausted, your muscles get fatigued, and you're breathing heavy. When you're coming down, what happens? Right, what happens next day? Next day is shivering. Next day is experience. You said you got me to the hill. What happens next day? Pains, cramps, injury. What happens when you're walking down? Your muscle is increasing in length and you are taking the load, right? So the two kinds of activities are can generate muscle endurance limits, muscle fatigue commonly, and their method is very different. Okay? Okay, now what are we going to do in the afternoon today? Is there any other question before we go what we're doing in the afternoon? So you wanted force, we're talking about fatigue. And I said co-activation I'll be doing later. I made you write a few points down. Can you repeat, please?
Prosthetic hand.
Okay, prosthetic hand control and what else?
Okay.
Okay, we'll do one of them now. Prosthetic hand? No, we'll keep the prosthetic hand later. Okay, we'll do prosthetic hand. Let's go and stick to this one itself. What is the prosthetic hand? Which are the biggest manufacturers of prosthetic hand? Powered prosthetic hand, how many of them are actually being used in the world, in India? How much do they cost? Anyone's got any idea? Yep. Otterbock in Germany is one of the biggest manufacturers, okay? And can you pass it on to the gentleman in the green t-shirt? Yep. What else? So Otterbock is the biggest manufacturer. Anything else you can talk about the prosthetic hand or?
They prosthetic hands and legs both.
Right. So are we talking about powered or are we talking about non-powered?
They manufacture both powered
Right.
as well as passive.
Okay. Can someone do a quick search and tell me how many powered prosthetic hands Otterbock sold last year? How many powered prosthetic hands were sold by Otterbock last year? Or Osur. Osur is the other company. I would say Osur is a better company. I used to be a consultant to them. How much does a prosthetic hand cost? Why not? There you are. If you go to Otterbock, they won't tell you. You'll have to go to Dr. Google or ChatGPT. They'll tell you. Did you get the answer? How much is that Otterbock? Okay. Huh? Anyone's got any answer to share? 8 lakh
Per
rupees
piece.
per hand. 8 lakh means in dollars would be around 10 to $15,000, right? That's the cost of the hand. And how much does it cost to fix it, to put it, to train the person to use it? How many hands were sold last year? Anyone's got some answers to share? Did you get any answer? Anyone? 31,000 power hands were sold last year. Hmm? Last year? Or are they talking about powered or non-powered hands? Powered hands? 3,000? The digital, so right. They are talking about nearly all of them are, when you are doing the search, I can tell you the answer is they're looking at what they call the finger. The majority of the people in the US, their lose is one finger. And so those are the prosthetics that they're talking about, and they're unpowered. So it's a synthetic finger which is put in there. Powered hands, if you check carefully, are typically sitting globally around less than 300. Why? Most people who require a powered hand, powered prosthetic hand, are generally speaking in the lower income strata. Most amputations of the radial amputations happen in lower income strata. Okay, I think India would be one of the largest. I know that Brazil is very high because why do they happen? Motorcycle accidents. You do not have many people in the affluent world driving motorcycles anyway. Fine? Right. So, and then you have got mines, which is again in countries like Vietnam, etc. So now those kind of things are not available, not causes of amputations in the affluent world. In general, by the time you buy the prosthetic hand, you do the training, you do everything else, the cost of a single prosthetic upper limb prosthesis typically sits at about $50,000, which many people who actually need it cannot afford. So here you have a situation that people who can afford it don't need it, and people who need it can't afford it. Typical situation worldwide. In the process, but there are other factors. You see, if it was something which really changes someone's life, people would still do something about it. But why does it not change someone's life? Now let's have a look at this. We are getting signals which have got a number of factors. Skin impedance, electrode placement, electrode distance, fat, muscle, end plate, etc. Now, when there is an accident and there's an amputation, what do you think is going to happen now? Big no. Okay? There is no one who's going to have some exactness. One person's amputation and the other person's amputation are going to be totally unique. And what else is going to happen? Phantom limb will also there, but that will be another bigger problem. We'll come to that later. But within this in itself, what is going to happen? When you go to the gym, your muscles bulge up. You go regularly to the gym. When the muscles are bulging up, what is happening? The end plates move, and the size of this changes. All of these things are going to change, right? If the muscle is not moving, there's dystrophy. The opposite is going to happen. Then there's a trauma. When there's a trauma, what's going to happen? That this entire end plate will drift. And in many cases, the end plate might itself be cut. Now, when you are picking up signals, and then you're going to use that signal to control a very fine device to do little actions like picking up this and this, these are fine actions. And with all of these fine actions, do you really think that your system is going to be stable? You know, when a baby is born, it grows, body changes, right? Similarly, when there's an amputation, the body is changing, it grows like a baby's body. The nerves regrow, some don't grow, some muscles come in the right place, some muscles come in the wrong place. So the body is traumatized. So what are you going to have? You're going to have a reasonably unstable system. What do you need in order for the system to be stable? You need lots of other pieces of information, contextual information. I'm in my office, I'm in my house, I'm in the kitchen. If I can get that information into the room, I'm sorry. If I can get something else into the place, I can get information such as, and more importantly, I need to then have someone who's a smart person who can put the electrodes correctly every day, do some measurements every day, need some calibration every day. Not something which a person who is living to pay off the bills can afford. That is why in affluent parts of the world, if you have a carer who's going to, a nurse who's going to come to do everything like that for you, it can work. Typically every 3 to 6 months, you need to recalibrate the system. And it can work. Now, having given this lovely news, now comes the good news. The fact that it cannot be working right now means that if you are a super smart person, you might be able to make it work. That means that you can now have to investigate all the factors that are going to go into it. So just sitting down and saying, I'll put a signal processing algorithm and get some AI and make it work, and in a lab and write a paper, yeah, you know, I'd rather make some better idlis. Point I'm trying to make is, if you want to do it, it is a great project to be part of, but the approach would have to be very different. You'll have to first consider who the end user is. What are their requirements? What do you need for all that? What are the factors that are doing it? Just because you have EMG doesn't mean anything. EMG can be garbage. In fact, more often than not, it is garbage if it's not used properly. So figure out what are the whole things. What are the conditions? Who are your clients? If a person is using this to drive a car or drive a motorcycle, and if there's even a small error, he or she is going to die and kill another 10 people. Are you responsible as a scientist, researcher behind it? You made a prosthetic hand, the person took it, got a taxi driving or a truck driving license. The truck couldn't control, went and killed everyone on the road. Hmm? Would that be okay? No. The point I'm trying to lead you down to is that prosthetic hand or prosthetic limb controls have been around now for 50 years. And you will find all over the world, ministers go, politicians go, they go on the stage, they get this guy or girl who can do something. I've done it myself, by the way. I got this woman who could use it to put lipstick on her thing. Why did I do a sexist thing like making a person do a lipstick? Doesn't matter. That was past tense. I did. And it went very well. And everyone looked at it and they clap and everyone goes home. Does it always work? No. The question I'm trying to make you go down to is, you have to identify. Yes, if there's a person who is gonna go to office and back and occasionally put lip gloss and do something like use a mouse, sure enough, these kind of things are very good. Make sure you know what the audience are. You know how many degrees of freedom. You understand the word degrees of freedom, right? How many degrees of freedom does your system require? My opinion is, I've written a paper on this 4 years ago, and Karthik was a bit think that I'm killing the field. No, I'm not killing the field. What I'm asking you to do is identify first what the requirements are. Who is going to use your product? Is it a general thing that you want to be able to give it to everyone on the road? You see, one big advantage in the recent past in the advancements has been that the actual prosthetic hands the prices have come down dramatically. What you are now seeing, 8 lakh, I think you mentioned, that is a German company, one of the very expensive companies selling it. If you were to make something similar yourself, I'm quite certain you could make it for less than 1 lakh of rupees. Okay, when you can get these motors, solenoids, and materials have become cheap. There's so many 3D printing is available. You can do that. You can do all of those things. You can build something for the individual. You don't even need to do any casting. You can literally build a 3D model for the person. Beautiful. All of those things are easy. It's a control which is becoming still a challenge. So a recent survey done in the United Kingdom was that people were more concerned about how it looked rather than how it behaved. So many of the people who bought even the powered prosthetic hand turned it off. But Touch Bionics, which is the company originally of Osso, what they provided was a real feel skin of the hand. That, to the user, was more important than the device. Now, that doesn't mean that everyone is the same. In their situation, that was the case. If someone has to do some physical work, they need a powered hand. No? So they can't do without it. If that is what is going to make them pay the bills, and then if they are a cleaner and if they need to be able to push the broom, they need the hand to push the broom. That's what gets them the salary. So you can't say, no, I'm not going to, I'm going to give you a good looking one. They're not interested in the looks then. The point is identify who is going to be the user. If you are going to be doing this, the first aspect would be, first, find out who the stakeholders are. Who is going to pay the bills? Who is going to buy the device? I have a device which is really good. I'll tell you what happened. I'll actually just change the topic and I'll give you this is a real life story, by the way. Many years ago, I was doing a project for the elderly, an aged care project. And it was about trying to determine if a person has fallen down in bed at night. Aged cares are becoming common in India too, right? Where when a person becomes old, they push them in and say, go away now, no more home. Your aged care is for you. So we went there and we had made this particular whole technology, video-based analysis, etc. So we said, this is great, it works, shown it works. Then we went to find out what are we going to do with the technology. So we built it. We took it to the aged care houses. Oh, this is the great stuff. Will you buy it? No. Why? Because the government has got minimum criteria on what an aged care center should have. And this is not one of them. So why would we are a profit-making organization? Why would I invest extra for something which is not required? Okay, go on. Then we thought, hang on, the children would be very excited. The children or the elderly people, because they would like to feel good about their parents. And they said, no, we are already spending so much money onto the aged care. And the elderly, in general, do not have any money left anyway by the time they're there. And even if there were, we went to one very high-end place. And one of the ladies, we were having a meeting with, 4 women there, elderly, and so one of them remarked, I mean, there were some personal remarks, but then it occurred that we had not considered these personal things. She said, what if I have got my boyfriend over and I'm having, sex with him? Right, we didn't think that elderly do that, but yes. Or one remarked something else, that I'm sneezing. You're going to record all of that. Okay. Now, then suddenly you understand that you built something, but there are no takers. You have got a device which works, and you think it is useful because it does work, and it has the potential of saving lives, but no one wants it. Right? So, for that purpose, in order to come up with a project, first thing is you should identify who your stakeholders are. Once you've identified the stakeholders, then you've got to identify what each of them requires. And many of them will say something which they do not understand. So if you tell someone, I'm going to give you a powered prosthetic hand where you can do everything, oh yes, that's great. But then when you give it to them in the hand, they don't want to use it. So the question comes down to is, this whole process is called co-design. Have you heard of this word before? Co-design? Anyone? No? Okay. So co-design is that before I start my project, I engage with my stakeholders to determine what do they think they want. That does not mean that that is what they want. It is simply that they think that they want. Then there is the next step. When you provide them with something and you say, is this what you wanted? And many of them will tell you, no. And then you have to engage with them to figure out what exactly is it that you wanted. And the question is, as engineers and scientists, we think that the others are fools. All of us, engineers and scientists, think that we know best. Okay? We don't realize that our engineering and science is meant for someone else. So if it is meant for someone else, find out what they want. Once you've done that stage, then you have to do to and fro to determine. I'll give you another instance. There was one little device which a company in Ireland wanted to promote. This was for slimming, the waist slimming. It's a belt or some description. I was in that meeting. I was not part of this. And this whole thing had failed miserably. Till one person came up with a very, very simple solution, which suddenly changed the whole thing around. And all that person did was change the color from green to pink. The green made people think that it's an army thing, and pink made it a feminine thing, and that was all that was required. Now you might think that's stupid. Come on, can't they think that it's going to work? It's green. In your eyes, maybe, but not for the user. Similarly, when you are doing any of these kind of stuff, like a prosthetic hand control, like the muscle force measurement, and we'll talk later about the muscle fatigue, identify what is the purpose of it. Are you trying, if you're trying to discover muscle fatigue relationship with EMG, sure, that's a research part. Do not expect it to go any further. Fine. But here, when you think prosthetic hand control, you're talking about a specific application. Determine what are the parameters that are going to go into it. So if it comes out that the only way you can it is effective is if it is less than 10,000 rupees, and you cannot make it in 10,000 rupees, well, you know that there's no point in even starting. Right? Okay, it is a great idea, but it is not going to go anywhere. Why waste your time and the government, the taxpayers' money to doing the research? But do it based upon facts. Right? Again, going back to here. Or if you know what you can deliver, based upon that, you can then fine-tune the whole project. If your project in whatever that budget and whatever it is only going to work for under temperatures of so and so, under force levels of so and whatever else, and with error of up to 3%, I'm just making up some numbers. If that is what it is, then you know that this is not something which a bus driver can use. It is not something which can be used while riding a motorcycle. But how do you control that? How do you stop someone from doing it? That means you have to now bring in the intelligence. So rather than doing anything else, the device might become actually more complicated, might have more AI, might have need some sensors to determine, hey, this guy is on a motorcycle, so let me stop the power, for example. Or determine if the guy is using it for driving a truck. No, you can't do it, it stops. I don't know, these are just some random thoughts, so don't take them seriously. The whole intention is, before you go down an application, identify the users, the stakeholders, and the limitations that would arise. Within that scope, then you scope it and take it further. What I'm trying to tell you is, it's an interesting project, but it needs a full, thorough investigation. Unfortunately, many of us, including myself, have done work in this on a very superficial level. And that is a waste. Okay, on that very cheerful note, now what I'm going to do is we're going to do a planning of the experiment for the afternoon. And I have been told that I am not going to be here. I'm going somewhere else. Karthik has offered to take me somewhere. So we'll get the work across to, I didn't remember your name. Huh? Hari Haran. Hari Haran and the company will work on it. So what are we going to do? One, what are we going to take the EMG off? Which muscle do you want to see? So working on leg muscles is going to be difficult because most of you are not wearing shorts. So let's do EMG of the upper limb. Easiest is biceps. That's the easiest one to work with. Okay. I want you to try both. I want you to try with the end plates in the center and end plates on the side. Do you understand what I'm saying? How many of you do not understand what I'm saying? End plates in the center and end plates on the side. Do you understand or don't you? You don't understand? Okay. This is your muscle. Approximately in the center is your end plate. In one case, we'll put the electrodes like this. In the other case, we'll put the electrodes like this. Okay? And I want you to see what happens to your recording. Fair enough? Hariharan, you will have to take a note down of all of these things. The second is I want you to do one thing. I want you to take EMG of the bicep in two parallel locations. So instead of having one here, another one here, just somewhere around here, another one here. You're using the same force, right? Third, I want you to repeat both of these for force. Near zero, maximum possible. Okay. Third, I want you to repeat the above 3 times. So what you're doing is you're doing the first one is you're doing this with electrodes on one side and electrodes in the middle, right? Then you're doing this for one set of electrodes here and one set of electrodes here. So let's say one electrode here, one electrode here. Yeah, simultaneously. Third, and you're repeating this for different levels of force. Okay? You're repeating this whole thing 3 times, but remember, each time you remove the electrode, you put them back. So you're not doing it that you do it once, stop and do it again. No. Do it, take it off, go away, go get a coffee, whatever, come back, repeat it. Okay? Yes. Right? If you can make a mark, fine. If you, whichever way. Okay. Take all of these and for yourself, maybe for every team you can have 2 people, otherwise it'll take forever. 2 people can volunteer to do that. I want to see mixed gender. So I don't want only men or only women. I want to see few men, few women. Okay. I would have also liked to help you determine age factor, but most of you are nearly the same age, so that won't arise. Okay. How much time do you think we'll take in this? Then I can go to the next step. how many equipment you have. So one device. So if you have got 10 people who are going to do it, this experiment would take about 10 minutes each. So we have 100 minutes. Okay? 100 minutes is no, 100 minutes is 1.5 hours. We'll make them go faster. Okay. Then, if time permits, I want you to now do this at least one experiment, only for one person. Okay? If you can do this and go up to fatigue. Actually, don't do fatigue today. No, we'll do that tomorrow. Tomorrow, I want you to do another particular thing. I want you to do this same thing. And while these are all isometric, the person did not move their hands. They kept it like that and they just kept it stationary. Now I'm going to repeat this whole thing with movement. So the person is doing this. Okay? Start with not near 0, 0. So there's no load at all. To maximum you can do. Okay? If you can do this much, that would be plenty. Then we will use this signal tomorrow, do some analysis. Okay? Tomorrow, make sure that you got your laptops. And if you, at least 2 people in each group should have a laptop with either MATLAB or Python, so that we can do some analysis. Okay? Fair enough? Everyone knows MATLAB a little bit, Python, MATLAB, familiar with? If you don't, sit with someone who does. Okay? Let's go for lunch.
So we can use the phone connected to the and look at that, and we can read that. We don't need to download the application.
Okay, 2019. In regard to prosthetic control, this is a paper which I will choose. Can you read it? So this is about prosthetic control and EMG control there. Okay. Can you read it now or? Identify. I would say for the prosthetic hand, my opinion on the prosthetic, my finding on this, that I have also, I think, if I remember right, identified potential future work. So you can't read it. So I think it download the Before you have lunch, then we'll do it. I will click you this. Okay. So, to that. Oh, you want to take it out? You can make display of that work better. You're doing modeling now, right? As a profession. Okay? Ali, I could take just a minute. No. And I'm getting. Okay? Let's see how sorry, I'm sure. If you make some mistake, you have to come to and t-shirt, you have what? Okay, recording your own. You're gonna do it on the laptop. You need something to your laptop. Yeah. No, there's no USB, is it? Okay. Okay.
No.
Oh, it's come. Okay.